Hello, science fans. Today we are going on an incredible journey inside our own heads. We are going to explore the human brain, the most complex and amazing thing in the known universe. Our story begins long before we take our first breath, see our first sunrise, or even have a name. It starts in the quiet, warm world of the womb. Just 2 weeks after conception, a tiny group of cells begins to form what is called a neural plate. Think of this as the very first blueprint for the entire nervous system. It's the beginning of everything that will make you, you. This delicate structure is the foundation for your thoughts, your feelings, and your memories. Around the 4th week, something truly remarkable happens. This flat plate of cells folds in on itself, creating a hollow structure called the neural tube. This tube is the ancestor of both your brain and your spinal cord. From the moment this tube closes, an astonishing construction project begins. The brain starts producing new nerve cells, which we call neurons, at an incredible rate. Every single minute, hundreds of thousands of these tiny brain cells are born. It's a biological explosion of growth, happening silently and unseen, preparing you for the world you are about to enter. These neurons are the building blocks of your mind. This rapid creation of neurons continues throughout pregnancy. It's like building a massive city from scratch, in just 9 months. By the time a baby is born, their brand new brain contains around 100 billion neurons. That is an enormous number, more neurons than there are stars in our Milky Way galaxy. In fact, a newborn baby has more brain cells than an adult will have. This massive collection of neurons is ready and waiting to start making connections, to start learning about the world, and to begin the lifelong process of shaping a unique human consciousness. It is a powerful starting point for the amazing journey ahead. So, at birth, we arrive with this incredibly powerful, but not yet fully connected computer inside our skulls. Each of these 100 billion neurons is like a person in a city with no roads. They are all there, but they can't talk to each other very well yet. The next stage of life is all about building those roads and pathways, creating a network of connections that will allow information to travel at lightning speed. The brain at birth is a world of pure potential, a blank slate ready to be written on by experience, sensation, and learning. The journey has only just begun. Once a baby is born, their brain gets to work connecting all those neurons. This is a time of explosive growth in connections, which are called synapses. At birth, each neuron has about 2,500 synapses, but by the time a child is 2 or 3 years old, that number skyrockets to about 15,000 synapses per neuron. This incredibly dense network of connections is what allows young children to learn so quickly. It's why a toddler can pick up a language, or even 2, without ever opening a grammar book. Their brains are like super sponges, soaking up information from everything they see, hear, and touch, and building a massive web of knowledge. As a child grows, their brain needs to become more efficient. Having too many connections can be slow and messy. So, the brain starts a process called synaptic pruning. Imagine a gardener trimming a rose bush. The gardener cuts away the weaker branches so that the stronger ones can grow and flourish. The brain does the same thing. It gets rid of the connections that are not being used very often. This makes the remaining pathways stronger and faster. This process is part of something called neuroplasticity, which just means the brain can change and reorganize itself based on experience. The more you use a skill, the stronger that brain connection becomes. Then come the teenage years, a time of big changes for the body and the brain. While the brain doesn't get any bigger in size, it goes through a major rewiring. A fatty substance called myelin continues to wrap around neurons, creating white matter. This myelin acts like insulation on an electrical wire, allowing information to travel much, much faster. This process happens from the back of the brain to the front. This is very important because the front part of the brain, the prefrontal cortex, is in charge of things like self-control, planning, and making rational decisions. It's the last part to get fully myelinated. This developmental sequence explains a lot about being a teenager. The parts of the brain that control emotions and rewards, like the limbic system, develop faster than the part that controls rational thought. This gap can lead to the mood swings, risk-taking behavior, and intense feelings that are so common during adolescence. The teenage brain is highly motivated by rewards and social connection, but hasn't finished building the braking system in the prefrontal cortex. It's not that teenagers want to make bad decisions, It's that their brains are built for seeking new experiences, while the center for weighing consequences is still under construction. By the time we reach our mid to late 20s, the brain's long construction project is mostly complete. The prefrontal cortex, the brain's center for executive function, has finally matured. This brings a greater ability to handle complex social situations, plan for the future, and regulate our emotions with more consistency. The brain has finished its major growth and pruning phases. It is now a highly efficient and powerful machine, fine-tuned by years of learning and experience. The brain's volume of white matter, the myelinated superhighways that speed up communication, typically peaks around age 40, making these years a time of high cognitive performance for many. However, even as the brain reaches its peak, subtle changes begin to occur. Starting as early as our 30s and 40s, we might notice the first signs of cognitive slowing. It might take a little longer to recall a name or learn a new, complex skill. This is a normal part of the aging process. It doesn't mean the brain is breaking down, but rather that its processing speed is changing. The brain is not a static organ. It continues to adapt. This is where the amazing power of neuroplasticity comes into play again. The adult brain is still capable of learning, changing, and forming new connections throughout life. One fascinating adaptation researchers have discovered is how older adults use their brains differently. For example, when performing a short-term memory task, a younger adult might primarily use the left hemisphere of their brain. However, an older adult is more likely to use both the left and right hemispheres to accomplish the same task. This suggests the brain compensates for age-related changes by recruiting more neural resources. It's like bringing in a helper to lift something heavy. The brain is clever, finding new ways to get the job done even as some of its original pathways become a little bit slower. During middle age, many people also find they get better at managing their emotions. Experience and a fully developed prefrontal cortex help us put things in perspective. Studies have shown that the amygdala, the brain's emotion center, in an older adult reacts less strongly to negative images compared to a younger adult's amygdala. This doesn't mean older adults don't feel things, but they may have developed greater emotional resilience. They have learned to minimize the negative and focus more on the positive, a skill honed by decades of life experience and a mature, well-connected brain. As we move into our 60s, 70s, and beyond, the changes in the brain become more pronounced. The cognitive slowing that may have begun in middle age can accelerate. The brain's outer layer, known as the cerebral cortex, starts to thin. This thinning often happens in the frontal lobe and the hippocampus, areas that are vital for higher-level thinking, forming new memories, and navigating our world. At the same time, the volume of white matter, the brain's communication network, begins to shrink. This means that messages between different parts of the brain travel more slowly, which can affect how quickly we can process information and react. The brain's chemistry also changes in later life. It begins to produce fewer chemical messengers, such as dopamine and serotonin. These chemicals are important for memory, mood, and motivation. A decrease in their levels can contribute to some of the cognitive challenges associated with aging, including a slower processing speed and more difficulty with multitasking. However, it is important to remember that this process is different for everyone. Many older adults maintain sharp minds by staying physically active, socially engaged, and mentally stimulated, which helps support brain health and encourages continued neuroplasticity. But what happens at the very end of life's journey? This has long been a profound mystery, but recent research is beginning to give us some clues. In one incredible study, scientists were able to record the brain activity of a dying patient. Just before and after the heart stopped beating, they observed a surge in specific brain waves. These brain waves, known as gamma waves, are associated with high-level cognitive functions like memory retrieval, dreaming, and conscious perception. This scientific finding provides a possible explanation for the light flashing before your eyes phenomenon that people report in near-death experiences. This research suggests that in our final moments, the brain may be replaying some of our most important life memories. It could be a final rapid-fire recall of significant events, a last act of a lifetime of consciousness. Other studies have even found that some organized brain activity can continue for several minutes after the heart has officially stopped. From its first spark in the womb to its final flicker, the brain's journey is one of constant change, growth, and adaptation. It is a lifelong process that shapes who we are, right up to the very end. Consider that,